Today, we are playing with digits, balancing out the opposite sides of an array, playing around with WUB WUBs and dubstep, and then we are incrementing numbers at the end of strings. Hello world, this is a nice shirt, and this is versus Codewars. We begin with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode, starting with a function that takes a string and returns that string reversed. Let's go ahead and get started with that. Our function signature looks like this, const solution, and it takes a string as a parameter. And what we do to that string, we split it into its individual characters using a blank string separator, take the resulting array and call reverse on it to reverse the elements therein, and then we join that string back together with a blank string. Let's go ahead and punch this into Codewars. And we are good on that. Our next warm-up has us finding the smallest integer in an array. Let's go ahead and do this one next here. Interestingly enough, this function signature is actually a method inside of a class. So let's go ahead and copy that over to our local solution here. And it looks like actually we are doing this. Yep, it's actually an array here. So what we'll do is we'll take our we'll return our args, and then we're going to run that through the sort method. In our predicate function, we're going to go ahead and take the first and second elements of our sort and subtract A and B. Let's go ahead and punch this into Codewars and see what that looks like here. And we do need to return the first element of that array, that resulting sorted array. And we are good on that. Our next warm-up kata, we are looking for a function that returns the sum of every number from 1 to the number passed in. The number will always be an integer greater than 0. Let's do this, const summation, and it takes a number as the lone argument. And we're going to go ahead and try this in a for loop. We're going to store our result here. For let I equals 1, I is less than or equal to number plus I, result plus equals I. And then we're going to go ahead and return that result. Copy that into Codewars here. What? I, not 1. I accidentally put in result plus equals 1 instead of result plus equals I. Let's try that again here. And we are good on that. Our next warm-up kata, we are using regular expressions to validate pin codes between 4 and 6 digits. ATM machines allow 4 or 6 digit pin codes. I must correct myself. It's not between 4 and 6. It's exactly either 4 or 6. So, let's go ahead and give this a play here. Const validate pin. PIN equals pin. Alright, we'll need a regular expression for matching strings with exactly 4 or 6 digits. So what we'll go ahead and do is const pin regex, and in our regex here, we're going to match one of two things. Either 4 numbers or 6 numbers. And what we'll go ahead and do, we're going to return the result of the regular expressions exec method on the string that we pass in. This should return true if it matches up a string with exactly 4 digits or exactly 6 digits. Let's put our beginning and end of string indicators here. All right, let's punch this into Codewars and see what that looks like. All right, what's going wrong here? Okay, all right, let's go ahead and console.log that pin here. And run that through Codewars, or rather our local solution, see what that looks like. Console.log validate pin 1. Let's run that through node here. Regex pin. Pin regex.exec pin. Interesting, it returns null. Okay, what we'll go ahead and try instead is return this pin regex.exec pin. Let's do a 2, 3, 4 here. And we get true, 5, false, 6, true. All right, let's go ahead and punch this into Codewars here and see what that looks like. And we are good on that. Our last warm-up kata of the morning is we are looking for the sum of odd numbers. Have a look at this pyramid right here. The goal of this kata is to calculate the sum of numbers in the nth row of this pyramid here, starting at index 1. For example, if you wanted to get to the sum of the numbers at row number 3, we would want the numbers 7, 9, and 11. All right, let's go ahead and play this one here. Const row sum odd numbers. Takes a row as a parameter. All right, this one could be a little bit of a doozy here. All right. First, we need to make our way to that row right here. First, we need to make our way to the row. And what I think we'll try here is... 1, 2, 3, 6... for let I equals 1, I is less than or equal to or less than row plus I. We're going to go ahead and calculate our start point first. Start index plus equals one, two, row, I think. No, I. All right, we're going to go ahead and console.log that and see what that looks like. I'm going to do this. Row sum odd numbers. We're going to pass in 2 here, for instance. We're going to run that through do and see what that looks like here. Warm up odd sum. We might actually need that less than or equal to sign here. 1, 2, 3. 1. Okay, I think I know where we're going wrong here. 1, 2. So let's try getting that 4th row here. 1, 2, 3, 4, 5, 6, 7. So we know where our start point is at here. Let's go ahead and do this. Let result equals 0. For let I equals start index. I is less than start index plus row plus I. Result plus equals I have something I want to try here. 2 times I minus 1. Yeah. For the sake of readability, let's go ahead and case these in parentheses here. Let's go ahead and console.log that and see what that looks like. $64, 13. I'm going to run a repo here. 13 plus 15 plus 17 plus 19. And that is right here. All right, let's go ahead and get out of the repo here. Let's go ahead and return our result. And console.log that return here. We're going to see what that looks like with some of our test cases here. Let's try 42. 74,088. That is what we were looking for. Let's try 1. All right, let's go ahead and punch that into Codewars and see what that looks like here. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Before I do get to that next kata, there is a better way I could have done that last warm-up kata. If you paid close attention into the odd numbers in that triangle, you would have seen 1, 3 plus 5, which is 8, 7 plus 9 plus 11 is 27. There's one thing in common with all of these sums. They can also be reached by taking the row and cubing it. A better way for me to have done that was to just return math.pow, passing in the row number and 3, get the row to the 3rd power. Given positive integers, int and power, the goal of this kata is to check to see if there is a positive integer, k, such that the sum of each of the digits of int raised to the successive powers of power is equal to the product of k times int. In other words, we want to check to see if the sum of those digits raised to their successive powers divided by the int passed in is an actual positive integer, which will be our k. We want to return that k if it exists, or minus 1 if it does not. Let's go ahead and get started with this here. Okay, what we first need to do, we need to get our digits out of int here. Got digits equals int dot toString split into its individual characters. And then I think that's actually all we'll need to do. Or what we'll go, but just to be safe, we want to parse them into ints. Alright, now that we have our array of digits here, what we'll go ahead and do is we'll keep track of our result here. Or rather our sum here. And what we'll do is digits.reduce digit. We'll set our initial accumulator here to 0. And what we'll do is return ec plus math.pow. We'll raise this digit here to our current power, and we'll apply the post increment operator to our power to increment it by 1 after we're done with this operation here. Alright, we're going to go ahead and console.log our sum here and see what that looks like. Let's do digpow, pass in 46288, and we'll pass in our 3 for our power here. And let's feed this in a node and see what that looks like here. Node playing with digits. And we should see our value 2,360,688, like this example right here. Now, we need to check to see if there is a positive integer such that the integer passed in here times that positive integer comes out to 2,360,688. What we can do here is calculate a quotient here. We can take our sum here and divide our integer. And let's go ahead and console.log that quotient right now and see what that looks like. And we do come up with 51, which is an actual integer. Alright, what we can go ahead and do there is return if quotient modulo 1 is equal to 0, which tells us that this is a positive, which tells us that this is an actual integer and not a decimal. We can go ahead and return that quotient. Otherwise, if it's a decimal and not an integer, we return -1 because there is no such integer k such that int times k equals our sum here. Alright, let's run some tests here and see what we can do with this. We've already established that this returned true. Let's try 92 and 1. And we do need to console.log our result now since we're returning now. Alright, let's try this. We do get -1. Let's try 89 and 1 here. We do get +1. Let's try 695 and 2. I expect to see 2, and we in fact do. Alright, let's go ahead and punch this into Codewars and see what this looks like. Run the tests. And we are good. In the reduce method's predicate function here in our Kata solution, you saw something a little bit strange. In the math.pow function, in the power argument, we passed in power plus plus instead of just power. What's going on here is a post-increment operation. The math.pow function will do its work with the power variable argument as is, but once that function returns, the post-increment operation will kick in, incrementing power by 1 for the next iteration of the reduced method's predicate function. Given an array of integers, the goal of this kata is to find the index of that array of integers such that the sum of the elements to the left of that index is equal to the sum of the elements to the right of that index. We are to return that index or -1 if no such index exists. Let's go ahead and get started with this one. What I think we'll go ahead and try here is, let's do a let left sum. Let's keep track of the sums on either side of the array here. And then let right sum equals integers dot slice 1. Then reduce ac int ac plus int. So what we're doing here, we're going to keep track of the sums of each side of the index here. We'll start with the left sum of 0, and then for the right sum, we'll take that array of integers, slice 1, so we get that array excluding the first element, and then we add those elements together with an initial accumulator of 0. Let's go ahead and console.log that and see what that looks like. Left sum, right sum. Alright, what we'll go ahead and do, we're going to go ahead and run that on this array here, console.log find even index, pass in that as an array. Alright, run that through node and see what that looks like. Node equals sides 0 and 0. Alright, what we'll go ahead and do here is, let's try another array here. Maybe this one. Let's try this one. Yeah, we have 0, and then 2, 5, 9, 12, 14, 15. 0 and 15 here. Alright, let's go ahead and for let I equals 0, I is less than, or rather, no, we do need that index here. For let I equals 0, I is less than integers dot length plus I. What we'll go ahead and do is, rather, for that I equals 1, let's try that. Left sum plus equals integers and I minus 1, and then right sum minus equals integers and I. Then if left sum is equal to right sum, return I, and then if left sum is greater than right sum, return -1. This is supposed to be I, not 1. So what we're going to go ahead and try here is, we got our left sum and our right sum here. We initially set our left sum to 0. And then we set our right sum to a value equal to this. We take our integers array, we slice the first element out of that array, and then we take the resulting array and run that through the reduce method to get the sum of the remaining elements. We have our accumulator and the current element of our array. We take the accumulator and add that element, and we have our initial accumulator set to 0. And that's how we get our right sum here. Let's do a little bit of an edge case here. If left sum is immediately equal to right sum, we return 0. If left sum is greater than right sum, return -1. That way we handle that edge case here. If that way we handle the edge case here if our left sum is equal to our right sum right away, or greater than right sum right away here. Alright, now we have this for loop here. We start at the first element of our integers array here, and then we go to the length of our integers array here. Alright, we take our left sum and we add the integer at the element before at index I -1 here, and then we take the right sum and subtract the element at index I. Then we run the checks again after that, and we repeat that until either we reach an instance where the left sum and the right sum are equal, or the left sum is greater than the right sum, in which case we return -1. Let's go ahead and run this through Node and see what that looks like. I expect to see 3, and we do. Let's try this array. Let's revisit this array again. I expect to see 0 here. Alright, let's have a look at some of our tests down here. Let's try 1, 2, 3, 4, 5, and 6. I expect to see -1 here, and we do. Let's try this array here. Run that again, and we do see 3. I like what we're seeing here. But keep in mind, some of the tests here may involve arrays with as much as 1,000 elements. That's something we're going to need to keep in mind here as we go. Let's go ahead and punch this into Codewars and see what this looks like. We probably won't see any empty arrays here, and we do have a problem here.
In the instance of negative numbers, the second minus 1 equal 84. Okay. Alright, that was a nice try, but I think I might have to find another solution for this. Let's...
Alright, things get complicated when we start introducing negative numbers. Alright, let's go ahead and get rid of that. Let's go ahead and get rid of that here. Let's just return -1 if we reach the end of this for loop without... Alright, let's try running the tests here again. And we are good. Part of what I was doing during the for loop of this Kata solution was taking the right sum, that is, the sum of the integers to the right of the current index of the array, and subtracting the integer at the current index of the array. What I wanted to do to save time was, in addition to checking to see if the left sum and the right sum were equal, I also wanted to see if the left sum was greater than the right sum, in which case I would return -1 early. What I did not take into account, however, was the fact that a number minus a negative number is the same as a number plus a number. For instance, 2 minus -2 is the same as 2 plus 2. There were some instances during this Kata's randomly generated tests where that oversight kept tripping the if statement if left sum is greater than right sum, incorrectly causing the function to return -1. By getting rid of that check, I was able to solve that problem and get the right responses from the tests. Polycarpus works as a DJ at our local nightclub, and he often uses dubstep music in his performance. Recently, he has decided to take a couple of classic songs and make dubstep remixes from them. We don't like that, so we're going to decode those dubstep remixed songs right back to their original forms. Given a string representing those dubstep remix lyrics, the goal of this kata is to decode those lyrics by removing the WUB WUBs from those lyrics and replacing them with spaces where appropriate. Let's go ahead and get started with this. I think this is going to involve the use of a regular expression. Alright, the kata instructions says that all the strings here will be all caps, so we don't need to worry about casing here. So what we're gonna go ahead and do, we're gonna create a regular expression. We're gonna call it WUB Regex, and this is going to, let's try a capture group here. This is going to match multiple instances of our WUB WUB. Alright, we're gonna go ahead and take this sample here. We're going to go ahead and console.log it down here. And what we're going to go ahead and do at first, we're going to go ahead and console.log lyrics.match. The string object's match method takes a regular expression as an argument and returns any matches in that string to that regular expression. We're going to pass in our WUB regex here. Alright, let's go ahead and feed this in a node and see what that looks like. And as you can see, it does pick up all of our WUB WUB WUBs in it. Alright, what we're going to go ahead and do here is we're going to do return lyrics.replace. We're going to pass in that WUB regex. And in their place, we are going to return a space. Now, in some cases, this is going to result in strings with leading and trailing spaces. We're going to go ahead and get rid of those with the trim method on the resulting string. Let's go ahead and punch that in a node and see what that looks like. And we do, in fact, see the lyrics, "We are the champions, my friend." Good song, you should listen to it. Alright, let's go ahead and pass this in a node and see what that looks like. Run the tests. And we are good. When using regular expressions to find matches in strings, capture groups and quantifiers can be leveraged together if you want to look for any number of consecutive occurrences of a sequence of consecutive characters in a string. Our WUB WUB, for instance, in our kata solution. Given a string, the goal of this kata is to check to see if that string ends with a number. If it does, this function will increment that number by 1. If it doesn't, the number 1 will be appended to the string. Let's go ahead and get started here. Take note of these examples right here. We have foo, we append 1 to foo because there is no number at the end of that string. Foo bar 23, the number 23 is present at the end of this string, so we increment it so that it returns foo bar 24. Foo 0042, the number 0042 is present here, note the leading zeros. We instead return 0043. If the number has leading zeros, the amount of digits found should be considered. Let's go ahead and give this a try, shall we? Alright, I think what we'll try to do is we'll do a regular expression here. Const number regex. And we'll do this. We'll look for any number of numbers at the end of our string. And what we'll try here is a console.log str match. Oops. Match number regex. Alright, let's go ahead and run this through our console.log here and see what that looks like. Let's take our foo0042 here. Console.log increment string. That's in our foo0042 here. Let's speed this into Node and see what that looks like here. Node string incrementer. And it does pick up, in fact, our 0042. So what we'll go ahead and try doing here is const replaced string, and what we'll do str replace. We'll pass in our number regex here, and we'll have a predicate function for our replacement value here. Pass in our match, console.log that match. And we have our 0042, of course. All right, we need the number of digits here. We'll keep track of the number of digits in our match here. And we do that by splitting our match by its into its individual characters, and then getting the length of the resulting array. What we're gonna try doing here is, what would a console.log ++ match look like? Let's feed that through Node, and I do believe that gives us 43. Now, what we will need to do is const new digits equals ++ match to string split dot length. Let's try console.logging a new digits and match here. Yeah, so what we're doing here, we're doing a pre-increment operator on our match here to add 1 to that before we work on it. We take the modified integer, convert it into a string, split that into its individual characters, and get the length of the resulting array. So what we can go ahead and try here is return a template literal array and new array, or rather 0.repeat digits minus new digits, and then our match. Let's feed this in a Node and see what that looks like. Yeah, we do need to return that, by the way. Yeah, and we have our foo0043. Now we need to handle another edge case here. 099 foo100. It seems that edge case has been handled all right. Foo0999 foo1000. Alright, it seems the number of digits is being properly considered here. Alright, I feel confident here. Let's feed this into Codewars and see what that looks like here. First, let's put in an empty string here and see what that looks like. That's going to be an issue here. It does not seem to be considering words with no numbers at the end here. So we do need to store that in our replaced str variable here. And if str is equal to replaced str, we'll return str1 here. Otherwise, return replaced string. Alright, let's go ahead and punch this solution here into Codewars and see what that looks like. Run the tests. And we got a problem. Invalid count, it's an error. Invalid count value.
Digits minus new digits. Now let's go ahead and console.log that here. Where are we going wrong? 2 to -1. Let's console.log that string here too.
Ah, okay. Let's put that in our local solution here. Alright, what we'll go ahead and do here is if new digits is greater than or equal to digits, turn match. Otherwise, let's try this. Bar 100. Alright, I think this will work. Let's punch this into Codewars and see what that looks like. Yep. Alright, let's try submitting it. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. Now, there is a lot of moving parts to this solution here, so let's break it down piece by piece. First, the last character of the input string is run through the parseInt method, and then the return value of that is run through the isNaN function to see if parseInt returned NaN, the not a number signature. ParseInt returns NaN if that string or character cannot be parsed into a number. So, if isNaN with that return value returns true, then we know that there is no number at the end of that string, in which case we just return the input string with the number 1 appended to the end of it. Next, let's have a look at the replace method below that. Pay mind to the regular expression you see here. There are 2 capture groups to that. The first capture group captures any number or no zeros. The second capture group captures any number of instances, at least one instance of any one of the numbers 0 through 9 at the end of the string. Now have a look at the predicate function here. Note that it takes 3 parameters instead of just 1. The first parameter is the match string to our regular expression here, which it's worth noting is not used here. The other 2 parameters are any number of additional parameters equal to the number of capture groups in our regular expression. So P1 is how many zeros were captured, and P2 is the number proper here. In the function body here, we have this variable up, which parses an integer from the match in our second capture group and increments that by 1. We then take the number of characters in that resulting integer's string representation and checks to see if it's greater than the number of characters in our P2 match, which would indicate if a 99 got incremented to 100 or a 999 got incremented to 1000, for instance. And if that length is greater than P2's length, we then take 1 0 from P1's match, which is the zeros that was matched up in a regular expression, and slices that out. So if we had like 3 leading zeros, we instead have 2. We take that resulting string and prepend that to the variable up to get our incremented string. Otherwise, we just go ahead and take all the leading zeros and prepend that to up to get our result. And that's going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.